The slides are visible?
Yes, ma'am.
Okay. So today's class is very important because you will get problems of this kind in the exam, which is very easy if you understand. And you will be able to score very easily. So please concentrate on the classes, whatever I take. Okay. Uh, Especially in the fourth module. This is fourth module. So you will get the question like this. Remove left recursion from the given grammar. Remove left factoring from the given grammar. Okay, this will be the question. So look here. So what do you mean by left recursion? First, that is the question. What do you mean by left recursion? So look here. In the previous class, we studied grammar will be of the form this. Okay. So grammar will be of the form this. Okay. So if grammar will be of the form this, something, okay, non-terminal, we call it as non-terminal, which will produce terminal or non-terminal, okay, which will produce terminal or terminal or non-terminal. That is the grammar. What do you mean by terminal? Okay, that may end. Non-terminal means that may not end. So end. So A produces A alpha or beta. This, what is the meaning of this grammar? A produces A alpha or beta is the meaning. Okay. So now what is left recursion? Left recursion means whatever there in the left side, okay, or LHS, okay, if that is present in the left side of the RHS, okay, we call it as left recursion. Whatever there in the left side, if that is present in the left side of the RHS, we call it as left recursion. So look here, A is present here in the left side. Okay, if A is present here in the left side, same A is present in the left side of the RHS. So I can say that there is a left recursion. Okay, this left recursion causes problem in top-down approach. It will lead top-down parsers to go infinite loop. Okay, so for now you just understand, if left recursion is present, it will go to top-down, it will cause problem in top-down parser. So we have to remove left recursion. Okay, so what is left recursion? Whatever there in this left side, if that is present in the left side of the RHS part. So A is present here, A is present in the left side of the RHS part, hence I can say that there is a left recursion. So let me go interactive. So you understood what is left recursion? Reply in the chat window. Suraj understood, Gaurav understood, Sachin, you understood what is left recursion? Okay. So if it is theory part, I wouldn't have stressed much. So since this is problematic part, please understand. Okay. So now, so this is the grammar which is having left recursion. So now, how to remove the left recursion? That is my problem, is it? How to remove the left recursion? Very easy. In 2 steps, I can remove the left recursion. So what is the first step, students? The first step is writing A produces beta A dash. A produces beta A dash. And what is the second step? The second step is A dash produces alpha A dash or epsilon. Okay. This single grammar can be written in two steps. First is A produces beta A dash, and then A dash produces alpha A dash or epsilon. So now if you observe, there is no left recursion in these 2 grammars. So one line grammar got split into 2 grammars, 2-line grammar. Okay, that is A produces beta A dash, and A dash produces alpha A dash or epsilon. So this is how we do it. Okay, now we are having a problem. Okay, so you write down this. You write down this. It will be easy for you to solve the next problem. It will be nice if you have a pen and paper with you. Okay, so look here. Remove left recursion. Important question in your exam. Remove left recursion for the given grammar. So what is the question we have got? Okay, we have got two grammar. Okay, here only one grammar was there to understand the formula. Here two grammar are there. So look here. Let me take the pen. So this is from both of them. I have to remove the left recursion. Whether this is having the left recursion? No, this is not having the left recursion. Whether this is having the left recursion? Yes, this is having the left recursion because A produces AC. Here also A is there, here also A is there, so it is left recursion. And again here SD is there. Okay, so when I observe, I can say that there is no left recursion here. But if you substitute, okay, if you substitute, what happens? If you substitute in the place of S can be substituted with AA. Okay, S can be substituted with AA, okay, or B. Okay, so two substitutions are possible for this. Look here, this is one substitution, and this is one more substitution. Okay, this is one more substitution. Okay, so S is equal to AA or B is one thing, and A is equal to AC is one thing, or SD is there. So SD I just substituted. S can be substituted with AA, so it became AAD, and S can be substituted with B, so it became BD or epsilon. This is nothing but I have just written the question. I have rewritten the question. I have just rewritten the question. Now the picture comes, I have to remove the left recursion. So here what happens? Whichever is there with the left recursion, that is considered as alpha. So in this part, so this is considered as alpha, A alpha. And here this AD, both is considered as alpha. And BD is considered as beta. And also epsilon is considered as beta. Okay. So we know the formula, right? For removing the left recursion. Just now I told you have to write this. If A produces A alpha or beta, then to remove the left recursion, what I should do? I should do A produces beta A dash. I'm just rewriting the formula for your reference. And A dash produces alpha A dash or epsilon. Okay, this is the thing. So now I'm having A produces A alpha. Here alpha is C. Here A produces A alpha, where alpha is AD, and A produces beta, where beta is BD, and A produces epsilon. So okay, so first grammar is not having left recursion. I'm writing as it is. S produces AA or VB. So second grammar, for this I have to apply the formula of left recursion. So look here, I am writing beta A dash. What is beta? BD is beta. BD A dash. Okay, one beta is over. Now second beta. Second beta is, I said epsilon is second beta. Epsilon means nothing. So beside nothing, you write A dash. So nothing A dash is nothing. It will become A dash only. So this is the first step. This is the first step. Okay. So this is the first step. Next, what is the second step? I should write A dash. So A dash is C A dash. Why C A dash? Alpha A dash. In this, C is the alpha, right? Alpha A dash. And then AD A dash, because here AD is alpha, or AD A dash, or epsilon. This is how I removed left recursion from the given grammar. So I'll repeat. So in your exam or internals, I will give question like this. Remove left recursion for the given grammar. S produces AA or B, A produces AC or ST or epsilon. Then you should be carefully looking whether this is having left recursion. No, this is not having left recursion. Okay, here left recursion is there. Okay, and here whether the left recursion is there directly, they have not indicated. You should produce you should replace S with AA or B. Then you will get this AAD or BD or epsilon. Now we know that the first grammar is not having any left recursion, but the second grammar is having left recursion. So here A produces AC, A produces AC is having left recursion, C is alpha. A produces AAD, AD is alpha, BD will be beta, and epsilon will be beta. So according to the formula, I will keep the first grammar as it is, and the second grammar beta A dash, BD is beta, beta A dash, or epsilon A dash. Need not have to write epsilon, epsilon is nothing, so A dash. Then A dash is equal to alpha. Alpha is C, C A dash, or alpha is AD here, AD A dash, or epsilon. Okay. So this is how we solve this. So next, we have the algorithm for eliminating the left recursion. Whatever we did now manually, same thing is given in the algorithm. So what you should do, you should arrange non-terminals in some order. Okay, that's what we did here. We arranged it. Okay, then for I is equal to 1 to n, for j is equal to I minus 1, replace. That means this is, where is my, this is one term, this is one term, this is one term. For each and every term, we will do it. Okay, for replace each production of the form AI AJ gamma by the production AI dou 1 gamma, dou 2 gamma, like that. Okay, and AJ is equal to this, are all the current AJ productions. Okay, so eliminate the immediate recursion among the AJ productions. Okay, so same example we have considered. So when I is equal to 1, what happens? We are considering first grammar, so there is no left recursion there. When I is equal to 2, I am considering second grammar, which will become like this after the substitution of S. And now what happens after removing? S is equal to AA or B, not having any left recursion, so kept as it is. But here C is alpha, AD is alpha, BD is beta, and epsilon is beta. So what happens? C A dash, AD A dash, and epsilon. And here A produces what? A produces according to the formula. Just recall the formula once again. So A produces beta A dash. What is beta? BD is beta, so BD A dash. Epsilon is beta, so epsilon A dash. Need not have to write epsilon because epsilon means nothing. So this is how we just solved eliminating left recursion. Okay, so it is completely based on the formula. What formula it is completely based on? This particular formula. You have to remember this. A produces A alpha or beta means A produces beta A alpha, sorry, A dash produces alpha A dash or epsilon. So we, in the next class, we will be solving many problems on left recursion. But right now, I just solved only one problem to make you understand what is left recursion. ಅರ್ಥ ಆಯ್ತಾ ಲೆಫ್ಟ್ ರಿಕರ್ಷನ್ ಹೆಂಗ್ ರಿಮೂವ್ ಮಾಡೋದು ಅಂತ? So you have to just remember, if A produces A alpha or beta anta idre, you will be writing A produces beta A dash produces alpha A dash or epsilon. ಅದೊಂದನ್ನ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ you will be able to solve any problem. Okay, next let us continue. um, Removing left factoring. Okay, next topic is removing left factoring. So, what is left factoring? So, assume the grammar A produces alpha beta 1 or alpha beta 2, A produces alpha A dash produces beta 1, B2. So, okay. So, this is the grammar. We will give you this is the grammar. This is having left factoring. So, what do you mean by left factoring? Left factoring means you have two production from this grammar A. Okay, one is alpha beta 1, one is alpha beta 2, maybe alpha beta 3, alpha beta 4, whatever. The first term is always same, alpha, but the second term is getting changed. So what happens? I will have the problem. What kind of problem I have? Okay, so from A, if I go to see, I'm supposed to produce the grammar alpha beta 2. I'm supposed to produce the grammar alpha beta 2. But since there is a match with the first literal, if I substitute that with alpha beta 1, then what happens? I have to backtrack. And again I have to substitute alpha beta 2. So it is consuming lot of time. Okay, when the first terminal is getting matched and the second terminal is not getting matched, it is taking lot of time. Okay, backtracking time. That's why we have to avoid it. So how to avoid backtracking? In order to avoid backtracking, what we should do? You should do it in two steps. You will write A produces alpha A dash. Okay, remember, A produces alpha A dash and A dash produces beta 1 and beta 2. That means in the first stage, you are telling first common symbol, and in the second stage, you are telling second uncommon symbol. Okay, so this is how we do it. Okay, so now we have the question. Left factor the following grammar. Okay, left factor the following grammar. Okay, so we are having two grammar given. Okay, this is the problem. Like this only we will give in the internals or exam. S produces IETS, S produces IETS, ES, and A. Okay, so for this we have to know this, right? Now what I should do? Okay, I should use the formula. So what was the formula? The formula was this. If A produces alpha beta dash, if A produces alpha beta dash or alpha beta 1 or alpha beta 2, A produces alpha A dash produces beta 1, beta 2. Okay. So now, so this particular grammar, what we should do? See, S produces, S is having left factoring. So here, okay, let me write the formula to ease A produces alpha beta 1 or alpha beta 2. Okay, then I should rewrite A produces alpha A dash. Okay, and A dash produces beta 1 or beta 2. So this is the formula. So here, what is alpha? Whatever is common is alpha. So let me take the different ink. Okay. So IETS is alpha. IETS is alpha. IETS is alpha. Okay. So what is beta 1 and what is beta 2? So beta 1 is epsilon and beta 2 is S. Okay, so look here what I have written. I have written S produces IETS and S dash, because IETS I have considered as alpha, and here nothing is there, so that nothing will be beta for this case, and here ES will be beta. Okay, so what happens? S produces IETS S dash, IETS S dash, and S dash produces or A. So A is not having any problem. I'm keeping it A as it is. ES, that is beta 1, and epsilon, that is beta 2. Okay, actually you can interchange and write, that doesn't make any alter the meaning. And E produces B. Okay, that completes the problem. So what I did here, IETS is alpha and nothing is beta, because IETS is common. Okay, ES is beta here. So A is not having any problem. So S produces IETS S dash or A is the first grammar. Then S dash produces ES. ES means what? Beta 1. Sorry, actually it is beta 2 here. And then epsilon. You can interchange, as I said, epsilon ES, that doesn't change any meaning. And E produces B. It is also not having any problem. So this solves left factoring problem. Okay, so that's all. So what? Let me quickly summarize what we learned in today's class. We learned how to remove left recursion and how to remove left factoring. So how to remove left recursion? The removing of left recursion is very simple. Okay, what is, if it is of the form A produces A alpha or beta, we should rewrite A produces beta A dash and A dash produces alpha A dash or epsilon. Using this formula, you can eliminate left recursion, and similarly, you can remove left left factoring. So how you can remove left factoring? When A produces alpha beta 1 or alpha beta 2, you can write A produces alpha A dash produces beta 1 or B2. So we have solved one problem in each case. Okay, in the next class, we will solve more problems. So just, I will share this slide, or if you have the textbook, you just go through this, how to remove the left factoring and left recursion. Let us solve problem in the next class. So you can enter your attendance and leave the meeting. If you have any doubts, let me know in the chat window.